class, so we back to this equation again. Okay, I will repeat again. So when your fx is even, therefore your Fourier coefficient Bn. So excuse me. Okay, Bn. Say only Bn. Okay, Bn is equal to 0. Therefore your general equation just now it become a0 over 2 plus summation n1 infinity an cos n by s over l only. So they have no Bn here. Okay, alright, so this is your if your fs is even. Okay, if your fs is odd, therefore your a0 and an are equal to 0. Both, okay, both a0 is equal to an and an is equal to 0. Means that a0 is also equal to 0. Okay, so therefore your equation for general one will become a0. Oh sorry, they have no a0 because a0 is equal to 0. You just have summation 1 infinity bn sine m pi s over l. That's it. So if you have a function odd, so your calculation will be more shorter lah compared to even. Not shorter, I mean if for even you still have a0, a and n, but for what you call odd, you just only have bn here because a0 and an are equal to 0. Okay, alright, so how to determine even and odd? So you need to refer my previous video. So how to determine it? You have two ways. Either you use a graphical, okay, you need to sketch whether it's a symmetrical on y-axis or origin, or you can use a equation. Okay, class. Alright, so yeah, so that's it about the formula first. So this is just introduction. Okay, but before we go to the example of it, they have some helpful identities. Okay, some helpful identities that we will use regularly in this chapter. Okay, so for the first one, okay, this one, okay, this one we already show you, we already get the answer in the previous video, sine and cos. Okay, so this is sine negative x, and we know that sine is an odd, kan? So sine negative x is equal to negative sine x, right? And then we also have cos negative x. So cos negative x, cos is an even, so it will become positive x. Okay, cos x. Okay, they have no negative outside here because this is even function, and the first one is sine is a odd function. And we also have, okay, this one may be the new things for you. Sine, sorry, not sine x, sine and pi. Sine and pi, okay, when you get this term, okay, when you found this term in your equation, you just directly substitute. Okay, substitute this one, sine and pi equal to 0. Okay, and then you also will be having 2 and pi. Okay, this one also is equal to 0. And cos and pi, okay, cos and pi is equal to negative 1 power of n. Okay, when you found this term cos and pi, directly you just substitute it, become negative 1 power n. Means that they have no cos and pi already. You will replace it with negative 1 power of n. And then the last one, the identities that we will find in this chapter, cos 2 and pi, and this one is equal to 1. It fits 1. Okay, alright, class. Okay, so this is some helpful identities, whereas we will find, right, the common one, the common equation for trigonometry that we will find out in this chapter. Okay, alright, so for the next video, I will show you the example. I will show you how to answer the question regarding odd, even, or neither function. Okay, class. Okay,